All right, math fans, this is Mrs. Hunter. I currently have strep, so that's why I sound like my husband right now. Um, I'm kidding. She currently does have strep, and unbeknownst to her, she's not the only one on the face of the planet that knows calculus. But she's much better at teaching than I am, so I'm going to give my shot at it. So antiderivatives. First things first, you're going to hear me say the integration is this or the integration is this. I mean antiderivative, and I will do my best to come back to this term every single time. Basically, but an antiderivative is basically a derivative backwards. Okay? So the way we're going to write it is the function big capital F of x is the antiderivative of a function. That's just one way we distinguish between the two. So if f prime of x equals f of x for all the x in the domain f, this process of finding an antiderivative is called antidifferentiation. So basically we start off with an integral. All right, that's that funky s, which I'm going to draw it like that. That's the only way. Miss Hunter's really good about giving the whole curly Q. Yeah, I can't do that. You can forget it. So basically what happens is we take this and we take the antiderivative of it and we call it capital Fx, and we add this this constant c. That constant c is essentially the vertical shift. That is your y-intercept, which you don't know. Unless you have a point to tell you on the original function where it is, you don't know. So for example, if I take the antiderivative and I get a quadratic, I don't know if that quadratic is here, or here, or here, or here, or here. It's somewhere shifted up and down. So that's what that plus c is for, to denote that we don't know exactly where it is, unless we get a point. All right. For all polynomials, notice that instead of multiplying the exponent and then subtracting the power by 1, we are going backwards. This means we will add one exponent and divide by its new power. So basically, here's what happens. All right. We are going to take your exponent and up it by 1, and then divide that by your new exponent. Okay? So if I want the, let's take the integration of 3x squared dx. Okay, to find the antiderivative, I would raise that exponent to a 3 and divide my coefficient by that new exponent. So 3 divided by 3 is 1. All right, so it just turns into x cubed, but I got to do a plus c. All right, plus c. Miss Hunter's favorite letter because, well, her name's Chrissy. So if that's your original f of x, so the integration of f of x would be capital F of x is the antiderivative.
Something else.
All right, so here's the deal. So what we're doing is we're gonna sketch this real quick. So I'm gonna go nyeh, nyeh, and basically I'm gonna sketch these as if C was something else. C were different possibilities. So if C were 0, if those are both 1, you're gonna have something that kind of comes up like this. That's what it's going to look like. If you said C was 1, so let's say it's x plus 1. Well, it's going to cross right there. It's going to be the exact same thing, but it's going to cross right there at 1 and kind of do the same idea. If it was at negative 4, so let's say negative 4 is down here. Let's pick a different color. I like blue. So say negative 4 is way down here. It's going to do the same thing, except... So that's x cubed plus minus 4. This is x cubed plus 0, which is just x cubed. Kind of redundant. And this one is x cubed plus 1. All right. So it's the same thing shifted up. That's why we have this plus c right here. Again, Mrs. Hunter's favorite letter. Cool? And again, marvel at my artwork. You should take it home here. I'll sign it for you. And you can one day get paid really, really big bucks by selling that on eBay. Find the general solution of the differential equation. So what they first want us to do is we want to do the derivative, the antiderivative. Give me an actual pen. The antiderivative of 3x to the negative 4th dx. All right, so what we're going to do is we're going to up that y equals. All right. And so y prime, no, capital, huh?
Just y.
Yeah, y is going to equal. So that up that's going to be negative 3. Or plus 1, negative 4 plus 3 is negative 3. Divide that by 3, that's a negative x, plus c. Okay, and then just to check, let's take the derivative of that. So if y equals that, remember you
Multiply the exponent.
multiply the exponent by the coefficient. So negative 3 times negative x is 3x. And if I subtract 1 from my exponent, that becomes negative 3, negative 4, I mean. And if you've got a constant out here, it just disappears. So that's y prime would equal that. So indeed,
No dx.
no dx? Okay, I forgot the rules for how it's been forever. I got Miss Hunter over here telling me how to do this. So I got this one matches that one, which is what we're supposed to be showing right now. Cool. Is there another one on this? It seems off the top. All right, let's turn the page.